All right, so we're going through the exam 2 study guide today. Hopefully that's going to help you with the upcoming exam. I do want this to be discussion, so if you want to put your microphone on so that you can ask me questions, I'd appreciate that. Otherwise, it's just going to be me talking, and that could be boring, or you might not understand everything. So let me know. Get that microphone on. Get your video on if you want to. You don't have to. I am recording this for those that aren't able to meet today's meeting. So if you just want to do voice, that's fine. I'm going to share my screen in a second, and we'll go through the study guide. Okay, so I'm pretty much just going to ask each of these, and hopefully as a group we can answer what each 28 points for this exam, or areas that I could ask questions on. See if we can answer what we think the answer could be, and as a group I think we will make sure we get all the answers that we need to be successful in this exam. So the first one says, know the energy held within fat. How much energy is held within fat? Who knows that answer? Shout it out.
9 calories.
That sounds pretty good to me. So we should know there's 4 calories from carbs and protein and 9 in fats, and 9 is for this one. Know the types of fat in the body. What different fats are there from the fat chapter?
Is that the triglycerides and phospholipids?
Yep. Triglycerides, which is 98% of all the fats we consume. Phospholipids, which are cell membranes, they're the fatty acid, the glycerol backbone with 2 fatty acids. Triglycerides are the glycerol backbone with 3 fatty acids. That's where the tri comes from. And then we got one other. Does anyone remember what the third type of fat is?
Sterols?
Sterols, yes. Which in the human terms, we most commonly see that as a cholesterol, but is a sterol. It's kind of a hormone-shaped, molecularly fat. That's how we create some of our fat hormones, vitamin D, things like that. Know the functions of fat. So what does fat do for us?
They protect the organs.
Yep, there's some protection.
Energy storage.
That's the main one. It is an energy storage. Yep, keep going.
Skin and hair nourishment.
Yep. You don't want yellowy nails.
Insulation.
Yep, it does insulate us, right? Keeps us nice and warm, but it also insulates nerve myelination around a nerve is a fat.
Hormone production.
Yep, like I mentioned just now, sterols help us do that. Why do we eat so much of it?
Taste.
It tastes so good, yeah. Okay, it's very palatable. We like the flavor of fat. That's what makes things taste so good. And that keeps us full for longer, gives us satiety. Okay, moving on then. That was all the functions. Number 5, if you were given a vitamin, know whether they are fat or water soluble. So first off, you know that vitamins come in either fat or water soluble in properties, so how they get into the body, how they transport. But then if I give you a list in the exam, you need to be able to know whether they relate to the water soluble or the fat soluble. So can someone list the water soluble ones that we've gone through in the chapter? I'll pull up the slides if we have to. Energy, what's our energy vitamins? What's in all the energy drinks?
Oh.
I can't believe no one's got an energy drink while they're studying for this. No one's can look on the label.
Vitamins,
Huh?
B vitamins.
Yep. B vitamins, we got B1, thiamine, B2, riboflavin, B3, niacin, B6, B12, pentathentic acid. They're all B vitamins. They help with energy production within the Krebs cycle and the electron transport chain. So that's B vitamins. That's one of the water soluble. What other ones are water soluble?
Vitamins,
Vitamin C.
Yep.
folate,
I didn't hear that one.
folate.
Folate
Yeah.
is a B vitamin. Yes, that's one of the Bs actually.
Okay.
Biotin and vitamin H, also water soluble. And what water soluble means, just as a added extra, it just means that it's transported with water. So we can consume mass quantities of these because we can just urinate excess out. They don't retain in our body. Whereas fat soluble, they store in fat. They transport in fat and they store in fat. So especially if you are more overweight or obese, that where you have more fat cells or larger fat cells, you can build up toxicity with fat soluble vitamins. So these ones you have to be a little bit more careful of. What's the fat soluble vitamins?
Vitamin A,
A,
D,
D.
E, and
E, and K. Good. So same sort of thing here for the minerals. We have two different categories of mineral. We have major and trace. Does anyone know what the difference between the two are?
Amount of milligrams you need per day.
It's the amount that you need. Yeah, over or under 100 milligrams. If it's over, it's a major. If it's under, it's a trace. So someone tell me the major minerals.
Calcium,
Calcium, need lots of it.
Phosphorus,
Phosphorus. Electrolytes, think about those. What do we have in our drinks?
oh, pot-
Magnesium?
potassium,
Magnesium, yeah.
Sodium.
Sodium.
chloride,
Fluoride is a trace. So I think we covered a few there. I can't remember which ones we actually said. Calcium, phosphorus, magnesium, sodium, chloride, potassium, and sulfur. Those are our major. And then our trace would be iron, zinc, chromium, fluoride, copper, manganese, iodine, molybdenum, and selenium. So know the common deficiencies in the US diet. So this is actually on every label. If anyone's got any food around them, they look at the nutrition label right now, it has to be stated on there at the bottom underneath all the different carbohydrate, fat, protein, all the different amounts that they have in there at the bottom. It'll say percentages of 4 different nutrients. Does anyone know what they are?
Is it vitamin D?
Vitamin D is one of them. Yeah, one of the 4.
Calcium, iron, and potassium.
That's it. So we tend to be deficient as a nation in those 4. So now they list those. They took out in 2018 the vitamin C, vitamin A, and replaced it with, I think it was potassium when they replaced it. All right, number 8, know the percentage of dehydration that affects performance. So at what point do we start seeing decreases in performance based on how dehydrated you are?
2
2
to
to
3.
3%?
Yeah, 2 to 3%. Exact identify what the question is. I can't remember exactly how they in the exam, but 3% is a great one to know. How much of the body is water? What percentage?
percent.
About 60%. Yeah. So there is obviously bone don't have as much fluid and hydration, so they're not as much, but then muscles are more than 60%, they're closer to 70%. So it averages out about 60% of the body is H2O by weight. And so then 3% of that, 2 or 3%, whatever you're weighing, that's not much. If you drop your weight 5 pounds or so, that's where you're dehydrated into that workout and performance is going to decrease. That's because thinking about that, why that happens. So you're connecting this to exercises. Think about blood volume. And if you're sweating and you're losing that hydration when you're exercising, you decrease the amount of water in the body, and blood actually takes the hit on that. So blood is mainly water too, and it can give water, but that reduces the blood volume in the body, which then is harder for the heart to pump around and supply nutrients to all the muscles. So it's all because of hydration by into the blood and then the supply of those nutrients to the muscles to have that forceful contraction in performance. So that's why water is so key. What functions does water play?
It provides cell structure.
It does, yep.
pH balance.
It does, yep. It's at 7. We like to be neutral. I just mentioned sweating. How does sweating help us?
Cooling.
All right, cools us down.
Hydrolysis.
Hydrolysis, or the breakdown of food, different chemical reactions. Yeah, and just this is a liquid that mixtures of chemicals can encounter each other. So it just allows for this medium of reactivity. How do we gain or how do we lose water in the body? How do you gain hydration if you need more water?
Food and water intake.
Yeah, that's simple, right? We have to eat or drink it. So 80% of our fluid comes from fluid. And then the other 20% of fluid comes from food. So we still get the water out of it. Things like lettuce, you think about how much material is in lettuce versus how much is just water inside those cells. How do we lose hydration?
Urination and sweating.
Yeah, urinating is the biggest one normally. Sweating is the biggest one during exercise. There's 2 other ways.
Defecation.
Defecation, yep. Sometimes that's more water we lost than we like. Insensible perspiration is the last one. So that's moisture in your hands, maybe your clammy hands. You could even, within your breathing, you have moisture in your breath. If you want to clean your glasses off, people can sometimes blow onto their glasses and create moisture to clean them off. That's again, other ways we lose hydration. That's really affected, that insensible perspiration or the breathing part, really in high altitudes where the air is drier. Just the rate of breathing will dehydrate you. So know the heat-related disorders. What things can happen if you overheat?
Heat stroke.
Yep, heat stroke is definitely on the severe side. Before that?
Heat cramps.
Heat cramps, I'm sure we've all experienced heat cramps before. One in the middle. After heat cramps, but not as severe as stroke.
Heat exhaustion.
Heat exhaustion, good. So going from levels of severity, you get the cramps, probably like I said, most of you probably experienced that where you're a bit dehydrated, working out, muscles start to cramp up. You need to get hydration, some electrolytes in there. If you don't address it, it can go to exhaustion and you're profusely sweating, trying to cool yourself down. And then again, if you don't address that again, past that, your body will stop sweating because it's got no more water really to give. That's not working and it will become dry. And that if you're out of breath, dehydrated and dry, that's a bad sign. You need to get you some help. Number 12, what is the adequate intake for water? Recommendations for adult male and female. How much water should you be intaking? You just did your self-evaluation. You should know what you need to take.
1.7 to 2.7 liters.
Close. Where did you get 1.7? It's
The slides, I think.
It's 2.7 to 3.7. So females at 2.7, males generally a little bit bigger. They need a little bit more water, 3.7 liters. That's quite a lot. It will depend on how much you're eating because water is part of that metabolic process. It helps you break down food. And we mentioned one of the roles of water. So it is a range normally due of how many calories you're consuming, but the adequate intake, the AI, is 2.7 for females and 3.7 for males for H2O. Know how to rehydrate. Okay, so after a workout, after a performance of some kind in sport, how do we know how much water or how much fluids to take in?
2 to 3 cups per pound lost.
That's it, yeah, 2 to 3 cups. So a cup is 8 ounces, so 16 to 24 ounces for every pound that you lose. You weigh yourself before performance, you weigh yourself after. All that sweat that you lose, all the heat that you're emitting, that's energy, radiation, you will lose weight. And we rehydrate with those 16 to 24 ounces per pound. What temperature water or fluid is best? Does anyone remember seeing that on the slide?
Isn't it 59 degrees?
Yeah, 50 to 59, kind of in there. It's about 14 degrees C. Know the abbreviations through all these chapters 7 through 12. So there's a few of those. I'll just call them off and you tell me what they mean. RDA, what does that stand for?
Recommended daily intake.
Oh, yeah.
Recommended daily allowance. Okay, should cover 95% of the population, the RDA. So 97.5. So 97.5% of everyone should need this amount of something. That's the RDA. REE. And you remember what REE could stand for? Resting energy expenditure. How much energy you expend at rest. BMI.
Body mass index.
Good stuff. Body mass index. So height to weight ratio. That's something that actually I would need to know. It's coming up on one of the next points. How to calculate that. There will be a question in the exam on that. RER. One of the newer ones that we just covered. Is to do with the rate of breathing and the energy that we're using to fuel exercise and how that changes our rate of breathing.
Resting energy requirement.
Not quite.
Respiratory exchange ratio.
That's it, respiratory exchange ratio. So this is a number that's between 0.7 and 1, or even can go to 1.1. That is basically, when we breathe in a mixture of all the gases that are in the air, the nitrogen, the oxygen, the carbon dioxide. We breathe those in and we utilize some of the oxygen, and we breathe out all those gases again with more carbon dioxide. But we also breathe out oxygen. That's why we can give that life-saving breath in CPR. We don't use all the oxygen that we breathe in. But when we exercise harder, we actually want to utilize more because we need more oxygen. So when we breathe in, a lot more turns to carbon dioxide. So the ratio of oxygen to carbon dioxide changes based on the intensity of exercise. The respiratory exchange ratio says that if 70% is coming back of oxygen going in, comes back out, then you're burning fat as your energy resource. That's low intensity. What you're doing probably right now, listening to me. But as you breathe heavier and you start exercising, you utilize more, you're more efficient, all oxygen is turned to carbon dioxide almost. And it's a 1-to-1 ratio, oxygen in to carbon dioxide out. And so that's a high number of 1. Can even go to 1.1, where you produce more carbon dioxide than you even take in oxygen. And that's another story for another time. But that tells you about fuel utilization. That would be carbohydrate at the higher intensity that you're burning rather than fat. TEF, what does that stand for? Something to do with food.
Thermic effect of feeding.
Yes, the thermic effect of feeding or thermic effect of food tells you how much it stimulates your metabolism to eat a certain food. Actually, again, I think that's one of the points coming up a little bit on the study guide, to know those numbers. So protein, carbs, fat, which ones stimulate your metabolism the most? Next up, we have TEA. Very similar to TEF.
Thermic effect of activity.
Yep. How much your activity stimulates your metabolism. RMR.
Resting metabolic rate.
Yeah, resting metabolic rate. BMR.
Basal metabolic rate?
Yep, and those numbers are pretty similar. One is just to sustain life and do absolutely nothing, while one is at rest. Pretty similar. Generally, BMR is just a little bit lower. SPA. This can sometimes also be called NEAT, N-E-A-T. SPA stands for spontaneous physical activity. NEAT stands for non-exercise activity thermogenesis. So it just means any activity that you do outside of exercise. So if you're a really active person, you like to walk a lot, you ride your bike to work or school, you play, do laundry, you do yard work, all those things that can burn calories with activity that is outside of normal workout exercise structure. Know what affects your BMR. So what would make you have a different metabolic rate to your peers in this class, to me, to your brother, your sister, your dad? What are the things that influence that?
Body size?
Your size, your height, your weight, even your age. What other things makes you burn calories? What will not burn calories?
Gender?
Yeah, your gender, what males and females, right? We are different body compositions. Body composition is another one. The more lean mass you have, generally seen in a male versus a female, how much muscle mass, that's an indicator of of metabolic rate. The more muscle, the more cell turnover, the more stress on the body, the more energy requirement to keep it functioning healthy. Yeah.
Climate and body temperature?
Yeah, temperature, right? We have to regulate our body to maintain a warm-blooded animals have to maintain temperature. If it's cold outside, we have to heat it up. If it's hot outside, we have to struggle to cool it down. Those things take energy, so they affect metabolism. What different habits? What's the whole class about? What could you all do differently when you eat? Okay, your diet is a big one. We talked about the thermic, or mentioned just now, thermic effect of food. The foods that you eat influence how they're metabolized. How much sleep are you getting? Gotta get your 8 hours is the recommended amount. Lots of negative consequences to not getting enough sleep. It is so good for you. What other habits could you have?
Level of activity.
Level of activity. I like that. Really, it's anything that stresses the body. That's stress to the body is going to increase the calories that are burnt to deal with that stress. So a couple of things that we haven't mentioned would be if you have an injury, if you are sick, if you have a fever, you know, the immune system's working harder. If you're a smoker, you know, we got that oxidation that's happening, not good for you, but it's also the nicotine that's a stimulant, and that stimulant makes you more active and burning more calories. Are you taking a lot of caffeine in, different drugs that may affect it? That again are stimulants normally. So lots of things can affect BMR. Just make sure you know what they are, know some of them. 16, know the total energy expenditure chart. So this was a slide on one of your presentations. I can't remember what lecture it was. And it has a sedentary lifestyle versus an active lifestyle. And they had some examples of how your energy is expended through the day. And now the majority of it came from that resting metabolic rate. And then a little bit came from the thermic effect of exercise. And then about 8% came from the thermic effect of food. Do everyone remember that pie chart? If you don't, go hunt it down, find it in your slides. So you know the difference between an active and a sedentary lifestyle. 75 compared to 60 with the percent of your total energy expenditure coming from resting metabolic rate. And the difference is because the total energy through exercise is more on an active individual than a sedentary person. So again, look those slides up. Number 17 says, know the hormones present in the menstrual cycle. I think I spelled that wrong, oops. You get the idea. What hormones are we looking at in that system?
Estrogen.
Estrogen, yep. One of the ovarian hormones. That's one of them. There are some others.
Progesterone.
Yep, progesterone. That's the other ovarian. And there's two others that are not from the ovarian, but they stimulate the production of those two.
Follicle stimulating and luteinizing.
That's it. Good job. So there's 4 different hormones there in that system. 18 says, know the thermic effect of the macros. This is one of the abbreviations that we went through on 14. So carbs, fat, protein all influence the metabolism, but differently in each of those. Which one has the most effect on metabolism? Which one promotes a higher metabolism?
Isn't it carbohydrates?
No, it's not carbohydrates.
Protein.
Protein, okay? Protein is hard to break down when you eat it. Okay, it's got that nitrogen component, and the others only have hydrogen, carbon, oxygen. But protein also has nitrogen. We got to get rid of that nitrogen as we break down this food. That requires more energy. Okay, it's a longer process. And then it's stimulating lean tissue, right? It's protein, so it's really good for our metabolism. Which one would do the least effect on our metabolism? It's a 50-50 guess. Come on. You can get it wrong now. Don't get it wrong in the test.
Fat.
It is fat. Good job. It promotes our metabolism about 3 to 5%. And it's high in calories. We mentioned it before. It's 9 calories for every gram. So it's over twice as energy dense as carbs and protein, which are 4, right? So it gives us lots of energy, and it's not that difficult to put into storage. So it doesn't really promote our metabolism get higher, but it gives us lots of energy. So it's a low on its thermal effect of food. Carbohydrates would be in the middle, about 5 to 10% promoting a higher metabolism, and then protein being the most promoting it with metabolism. So we've talked a lot about calories. What is a calorie? Anyone? What's a calorie? No one?
A unit of energy.
Yes, it's a unit of energy. Okay, it's equivalent to 4.186 joules, okay, or kilojoules for a kilocalorie. Okay, so we eat energy, we expend energy. It's just a system of energy being pushed throughout everything. We eat things, we excrete, we expend, or a nature cycle. Know the normal RER values. So that respiratory exchange ratio, I already mentioned those as I explained what RER is. That's 0.7 for fat, all the way up to 1 for carbohydrate. And it looks at the fuel that you're metabolizing. 21, know the ergogenic aids. So what are the different types of, what does an ergogenic aid do first?
Enhances the ability to produce work.
Yep, helps you do work, right? Helps you do stuff. When we talk about athletics and sports, it's what makes you stronger, what makes you faster, what makes you more powerful, all those sorts of things. Okay, and then come a few different types. Okay, nutritional for this class. What are some ways that we could aid our ability to produce more work by eating something? What sort of things could we eat?
Protein powders.
Yeah, that would work. It's something that we don't, it's a supplement, right? We put into our body, and now we are able to have bigger muscles as a result. So it's not quite that simple, but you get the idea. What's another type? There's 5 different types. Anyone got that slide open?
Psychological.
Yeah, psychological,
Biomechanical.
biomechanical,
Physiological,
physiological.
pharmacological,
Yes. So those are the 5. So nutritional, something like Gatorade that you can drink, protein powders, multivitamins. We said psychological. So those are things like visualization, pre-shot routines, things that help you do better. I think then it was biomechanical you mentioned. So think about a weight belt or KT tape on your body. Then we said physiological. So idea of maybe sodium bicarbonate, being able to consume that. It could maybe come under nutritional with that maybe. Maybe we'll look at doing a good warm-up. That's a physiological way to enhance performance. And then you had pharmacological, so some sort of steroid, some sort of hormone or prescription drug that would come from a pharmacy. Easy way to think about it. 22, know what nutritional information is allowed to be given to the public. So unless you're a registered dietitian, what things, you've taken this class now, you know a little bit about nutrition. Should you be telling anyone about how to eat and drink? What sort of information can you tell them?
General knowledge.
Yep. So we call that stuff that is in the public domain. Okay, so that's resources, right? We can be a resource to whoever it is that we're trying to help. We can say, look, go onto the government resource website. Here's the My Food Plate. Used to be the food pyramid that gives you some guidance on what to eat. Here's the registered RDAs, the registered daily allowances. Protein should be this much based on your body weight. Carbs should be this much based on your body weight. Fat should be this much. But it's a range. You can't tell them where in that range to eat. This is just the guidelines that are in the public domain. You can share information that maybe you read in your journal articles, which reminds me, you will have case studies to submit for your supplement project. So get me those case studies submitted. When are they due? May 7th. You got some time, but I'll talk a little bit about that after today's prep. So textbook information, you can talk about textbook information. I read this in the textbook. My professor taught me this in class. This is information that you can share with people. And then food labels. So you can tell them, look, this is the food label on the back of your food. This is how you read it. This is information. You just can't prescribe any food, any diets to anyone. That's unfortunately commonly seen in like social media nowadays. People do it far too often. And they're really just putting themselves in a bad position because it's out of their scope. And unless you're a registered dietitian, you can get sued basically. So careful with that. 23 talks about supplements and know the information that should be written on supplement labels. So what are the different claims that can go onto a supplement label?
Nutritional, health, and structure.
Yes, yeah, nutritional, which says, you know, this is a good source or a high in something or low in something. It tells you about what the nutritional information of that product is, and it has to be in accordance with the FDA, right? What the RDA says. So if the RDA says you need 130 grams of carbs a day, well, this is a good source of carbs, or, you know, you need this much calcium. This is a good source of calcium. If it's got, I think 20%, it becomes a good source. But those are available on the FDA website where you'll learn that information. Health claims talk about the health benefits of eating this food based on the nutritional claims. So if something is, like I mentioned just now, a good source of calcium, then I can say, well, consuming good amounts of calcium leads to stronger, can decrease the risk of osteoporosis. And then I could have a functional claim that says calcium strengthens your bones. So calcium's function is to strengthen bones. Its health claim says it can reduce the risk of osteoporosis. And the nutrition would say this is high or low or something in that product. So 3 different types of claims there. Then we're getting to more of your consultation types question stuff. Know the health history questionnaire and what it includes. What sort of things would be on a health history questionnaire? You probably all filled these out before at the doctor's office.
Family history,
Yep, family history.
chronic diseases, injuries,
Keep going. I'm sure you're reading the list there. Keep going.
surgeries, lifestyle, medications, and self-perceptions.
Yes. So all those things that can influence your day-to-day life and what nutrition maybe you need based on that. Again, think about stress of the body. That's really where food comes in. It helps you deal, gives you the energy to deal with stress. So all the things that can give you stress, not just psychological stress, although that is self-perceptions is one of them. Everything in your lifestyle and in your genetics, your family history that will add stress the body's got to deal with to maintain life. 25, know the psychological readiness scale. So those 6 stages, does anyone want to read those out?
Pre-contemplation, contemplation, preparation, action, maintenance, and termination.
That's it. 6 stages. When you're not thinking about changing, when you think about changing, taking a step towards making that actually a reality, making it a reality, maintaining that new habit, lifestyle change, and then when you don't have a chance, past about 6 months that the action's been happening, it's terminated, and there's no longer really a change scale. 26, know the body comp assessments. What's the gold standard for body composition testing?
Hydrostatic weighing.
Yeah, it's kind of the old school, but it's still the gold standard, using the Archimedes principle of how much volume of water moves when you go underneath and your weight underneath the water. Okay, hydrostatic weighing. How else can we do body composition?
The skin fold test.
Twofold, good, yep. Does anyone ever
BIA.
what is that? BIA, good.
DEXA.
DEXA, BOD-POD. Good stuff. Know the skin fold location sites. So there was a slide covering, is it Jackson and Pollock's equations there, I think on one of the slides, on how you can calculate body fat percentage based on the skin fold measurements. And it went through, you always take skin folds on the right side of the body, and you do it in a few different areas. Females never get the chest done, but males can have the chest taken. Triceps, subscapular, mid-axillary, abdomen, suprailiac on the side of your stomach, and thigh. Now there are other ones. There's also some equations that use less than those. For the exam, know those ones that I mentioned, and know the direction at which you take them. Is it a vertical line? Is it a horizontal line? Is it diagonal line that you take that fold? Make sure you know that. 28, know how to calculate BMI and fat mass. How do you calculate BMI?
Kilograms divided by meters squared.
That's it. Yep, kilograms over meters squared. So make sure you know how to convert kilograms to pounds or pounds to kilograms, because you need to know how to do that. And then meters into feet and inches. So for those that don't know, there are 2.2 pounds in a kilogram, and there are 2.54 centimeters in an inch. There are 12 inches in a foot, so you can figure out your 5 foot, whatever, you do 60 plus whatever change that you are, times 2.54, that gets you centimeters. You got then divide that by 100 to get the meters, kilograms over meters squared. So make sure, give that a practice maybe before the exam. There's definitely a question where you have to calculate BMI, and then know that the scale after that. So what's good, what's underweight, what's overweight, what's obese, because you'll calculate it and categorize one of the questions. That's everything. Any questions anyone else has before I go through some other points for the class?
What are some major formula equations that we need to know?
BMI's one of them. I don't think there's many others. I don't think there's any others.
I can't remember. There was one on our quiz that we used.
One on what?
On our quiz. I can't remember if it was last week's or the one before.
I don't remember. I'd have to go into the Blackboard and have a look. I can try to do that. Let me see. I'll look that up. Anyone else have any questions while I do that?
I know you said that only licensed nutritionists can prescribe a diet, but would a licensed physician be able to? Because if someone's diabetic and they prescribe a low sugar diet, is that?
They would normally, so there's a healthcare continuum. Now, I'm not a complete expert on this, but I would probably say that a physician would tell you that you need to be on a diabetic diet, but they would refer you to a nutritionist. They would refer you to a registered dietitian. That's
Okay.
part of that, that referral network is how the whole industry works. And so they would probably just refer you out. Any other questions? Okay, I want to cover a few things. So you just submitted all of your self-evaluations last week. So hopefully you found that useful. Hopefully you applied those questions to yourself, which is the whole point. Noticed if you weren't eating enough, or you're eating too much, or you weren't exercising enough. Hopefully this class teaches you something about your lifestyle and how you can make it a little bit better. Highlight some issues to improve. Like I said, case studies are due May 7th, as well as your paper. And so if you haven't already chosen a supplement, I asked for that on week 2 of this semester, maybe even week 1 after look through the announcements, but it was a long time ago. Make sure you're getting that supplement chose so that you can write that paper and produce at least 3 case studies for resources that you're retrieving information from this research, and then you can write about it in this paper. This is the supplement. This is what it does to the body. I know this because I saw it. I read this in the research. You want to get some real sources on this information. You can do more than 3. I only require 3 that you submit on Blackboard, but you can do 100 if you really want to. Exam 3 is coming up on May 4th. We're going to do a prep on May 29th. April 29th, sorry. April 29th is the prep. Exam is on May 4th. And that's covering strength athletes, endurance athletes, team sport athletes. We've learned all this information up until this point, up into the 2nd exam. The 3rd exam is all about applying that information to a strength athlete or an endurance athlete or a team sport athlete. We also learn about special populations and then how to calculate out these numbers, how to tell someone, how to figure out how much protein someone should be eating. Now, you're never going to recommend it to anyone, but you should be able to go through that process of figuring out how to calculate your own numbers. Okay, so we're going to teach you how to do that through this next few lectures. And that's it, all the info I have. So I'm just going to look on homeworks just to check on this calculation question.
Is the exam open 8 to 5 again?
It is.
Okay, thank you.
And is the May 4th exam the final, or do we have a final in addition to that?
That is the only, yeah, that's the last exam.
Thank you.
Oh, so maybe this is one of the questions here on homework 6. It asked about calculating resting metabolic rate through the World Health Organization equations. That isn't going to be in exam 2, but it will be in exam 3. There's a lot of calculations in exam 3. You will need a calculator, pen, paper. You'll need to practice those, but we'll cover that later. And like I said, there'll be a prep before exam 3 as well. But make sure you go through the calculations lectures after exam 2 and learn how to do those calculations. It's a big part of exam 3.
All right, thank you so much.
All right. Wow. On that note, I think we are done. Thanks all to tuning in and getting some info. I wish you the best of luck in this exam. And see you later.
Professor Sykes,
Thank you.
are you going to be available for like